So how many of you actually traveled from outside of UK for this conference? A big chunk of the room. How many of you traveled from other sides of UK to London? A few. And how many are actually, living and working in London? Okay, great. So how many of you, last question, how many of you are going to stay for the weekend in London? A couple of you. That's good. Well, hopefully you enjoy it. I want to start with a little bit about me, because generally when I do presentations or seminars like this, I forget to introduce myself. So I was thinking what to say, and it hit me. All of a sudden I realized that the person that I think I was didn't match the person that I was in reality. Did anybody has such a profound experience? Okay, good. I'm not alone. Because if you ask me whether, let's say, do I love reading, I would say, yes, absolutely. But then I realized that I just buy the books and never read them. I actually buy a few books at a time, generally to get the free delivery of Amazon, obviously. But then I put them in the shelf and leave them there. I realized in one of those books, which I read the first few pages, that there is a term for that in Japanese. It's tsundoku, the state of mind of buying books and never reading them. So it's like book hoarding. So sometimes I motivate myself to get a book and read. Then I go to the shelf, look at a few covers, all of them look like interesting reads, and then I go back and watch a few more YouTube videos. So this is what I do with books. Also, I love sports, or at least the idea of doing sports. Healthy living, etc. It's very buzz nowadays. And I've done actually a little bit of sports. I've done squash years ago, rowing a little bit, although it was a bit odd. And this is me holding on for dear life 8 years ago, because I couldn't find any more recent pics doing sports activities. But I do have a gym membership, and I pay every single month. If you think about it, I increase the demand so that it's cheaper for other people. Very altruistic. And I want to start, either squash or rowing, but I don't know which one. I'll decide by the end of the summer, hopefully. One thing like a hobby that I really love and actually do is traveling. But my traveling is a little bit odd, because every year I go to the same places in the same period. So the other day I was scrolling my Instagram profile, and I realized that I have 2 exact photos of the same place from the same spot a year apart. So this is a lovely Manhattan sunset with a year apart. If you look at the photos, nobody will believe that I was there twice, because they are exactly the same, with a little bit difference in maybe the clouds. But the one from 2018 has more likes, so it's a win. So I guess my problem in life is, making decisions, like choosing stuff. And the topic for today is actually how to make choices with Tableau. So I'm not sure whether I'm the most qualified for, making the right choice. But if you think about it, you can have a framework in Tableau, and it can help you to choose the right calculation type, which we don't necessarily have in life often. But we'll talk about this framework today, and hopefully you will leave this room with some understanding of how to make the right choice for the right calculation type for the right analysis. So the agenda for today is to talk about why actually we need to make a choice, what it brings us into if we do the right choice, and then we'll go a little bit to the basics of Tableau, because if you understand how Tableau works, actually making the choice is much, much easier. Then we'll see a little bit of practical examples, and at the end I will summarize it in a generalized framework of how you can make the right choice. And then we'll have, hopefully, some time for Q&A. So what's the purpose of making the right calculation choice? I had a course in university called Monetary Policy. And basically there, the first time I realized that everyone needs to make a choice, even if you're in the top of the pyramid, you know, if you're running a country. So in monetary policy, they have this policy trilemma, or the impossible trilemma, as they call it sometimes, that between free capital mobility, independent central bank, and exchange rate management, you can select only two and leave the other one to the markets, basically. So if you think about market economies, generally they select free capital mobility and independent monetary policy or central bank, which means that the exchange rate is determined by the markets. So you have different combinations of these two choices, and every time you need to leave the third one to the markets. For example, if you think about China, they are actually coincidentally C, because they have independent central bank, but they manage their exchange rate, so they fix it or they play with it. So that's why they can't have free capital mobility. That's why we don't see, you know, Chinese currency in the change bureaus. If you think about Tableau, you can find similar concept for a trilemma, but this time in Tableau it's between simplicity, flexibility, and performance. So most of the time you will not have to make a choice. You will have all of them for granted, but in some situations you may end up having to choose between these two of them, and you need to prioritize basically. So making the right choice, depending on our priorities, will help us to select the calculation type that needs, that will help us to put out those priorities in the right order. But it's not only that, it also helps us in all of these areas. First of all, obviously if you make the right calculation choice, it will save you time because it will be much easier to write that calculation and then later on to maintain it. And also, the correct calculation type will bring you the best performance for the use case that you have, which will also increase the collaboration in the organization or the team. Imagine that you need to do part of the work and send it to somebody else, or they need to expand on your work. So keeping your work simple will help you to collaborate more within the team and the organization. And finally, with more collaboration, it comes more adoption. So the work that you do, the dashboards or the analysis that you create will be more and more used within the organization. So let's talk about a little bit of the basics of how Tableau actually do calculations. Because as I said, this is the backbone of understanding the framework that we will discuss today. So understanding these simple elements or aspects of Tableau will help you do the right choice. Maybe some of you have been to sessions related exactly for the specific topic. We'll just summarize those conclusions. So if you think Tableau from a consumer perspective, I see it as a water tap. It needs to be elegant, modern, but very simple. It needs to do a very simple task, to give you the right amount of cold and hot water as you wish for the specific task. So a dashboard needs to be as simple and as elegant and easy to use as a water tap. Obviously, when you see this for the first time, and you're like, okay, I need to question now everything that I know about the world up until now, right? And I said, I will never live in a house with this type of design. I need to learn to never say never, basically. So, but from a dashboard creator or an analyst perspective, we can't, so if we think about the consumer, they don't have to know about where the water comes from, what was the cleaning and filtering process, what was the pumping mechanism, etc. They just need to, play with the handle or whatever it's called. But from an analyst and designer perspective, we need to answer all these questions. Otherwise, we will not be doing our jobs effectively. So that's why understanding the data structure as a start is very important, or understanding the granularity of that data structure. If you think about these Lego blocks as your data, you need to know what type of blocks you have to know what you can create out of those blocks. And the funny thing about Tableau is that it works a bit like a magic. So you have some data, and then you have these tiny tabloids who build the viz for you. But you don't have actually, in Tableau desktop, when you start building, you don't have the visibility of that data anymore. So if you don't know how the data looks like, you will not be able to create what you want, or maybe your interpretation of the results will be wrong. Imagine that instead of a house, you want to create a ball. Well, you can create something like that resembles a ball, but it will not be a perfect ball because all of your Lego blocks are rectangles or squares. Let me give you an example with a very small data set. Imagine that you have a survey data where the only question is basically how satisfied are you overall. And you do the survey, and the results are pretty good on average. And then a few months later, you just check the results again, and you find out that the results have dropped dramatically. And you're a bit worried what's going on. But then you realize that one person, Marius, has filled in the survey 3 times. And if you have noticed, his score in May 2018 was the lowest. So apparently he's very pissed that things are not going in in the direction that he wants. So he filled it again and provided less and less score. So obviously, because of Marius, our score is now really, really low. But the better way to look at the data would be on a participant level, not on a survey ID level. So instead of averaging those individual scores, it will be better if I average them first on a participant level and then take the average of those averages. And here comes the nice thing about LODs and table calcs. In Tableau, using basic calculations and simple drag and drops, you can get only to the first set of results. So if you want to do secondary aggregations, you want to do something like more complicated with the data, you will need LODs or table calculations. But if you don't know what each record of the data means, you will never actually assume that you need to use table calcs or LODs to come to this result. So that's why it's very important to know what record of the data means, so that you can understand the results better. The second topic that we will discuss is the viz level of detail. So viz level of detail probably is something that you have heard often when you use Tableau. It's basically how you break down the results in Tableau. Which dimensions do you use to summarize the data that you have? So if you think about the data, then it comes to Tableau, and you say to Tableau, create some houses. And then in Tableau, you just see the houses themselves in the shape that you want. Imagine that the question is how many blocks we use to create each house. And if we drag and drop houses, we have the answer on a houses level. But then, instead of houses, if you drag and drop streets in the data, then Tableau will summarize the data on a street level. So in this case, your viz level of detail would be streets. But then you can go further. You can drill down and say, okay, I have the street level, but I also want to see the houses level. So you drag and drop houses again, and then you have your viz level of detail on streets and houses level. So this will help you to understand what type of information you have on the data. And it's very important once you start doing table calculations, for example. So if we look at the example with the data again, what we have is different results on different level of granularity or aggregation. So from left to right? Yeah, left to right we have more aggregate, and from right to left we have more granular level. And you can display this information in Tableau on any level that you want. but you need to know at what level you are when you are doing the analysis. So another important point is where actually the calculation is happening. So we have the data level and the Tableau level as the two options. So basic calculations like sum of profit divided by sum of sales for calculating the profit ratio, they happen in the data level, which means that Tableau sends a query to the database, and the database is actually doing the calculation. So we use all the data that we have, except if we are filtering it. LODs, the same way. Level of detail expressions, they go back to the database. So we can use all the data that we have. But on the other hand, table calculations happen on the Tableau level. So if you don't have anything on the view, there is no way you can calculate, you can run a table calculation. So that's why it's also important to know at what level you are summarizing the data so that you understand what type of table calculation you can do. Let's go to a few examples and see all of these concepts in action. So we talked about performance, simplicity, and flexibility, and I want to show you a few examples of how you can achieve each of those aspects using LODs or table calculations. The data that we have today is the property transactions in London since 1995. So it's a very big, extensive data set. And this is how it's structured. As we said, the first thing that you need to do is to understand the data structure. So we have transaction ID for each property sale. We have which borough the property was located on, postcode, what type of property it was, whether it was new, old, freehold, lease, etc. And I know that each record in my data is a transaction because if I drag and drop number of records, which is created by Tableau automatically, and it gives the value 1 to each row, I can see that the result is only once. So a transaction ID equals to 1 row of data. So knowing this, let's start with 2 examples for simplicity. How we can simplify our calculations depending on what we have on the view. So the first example that we have is trying to calculate averages. So on the view, I have the average price for each district in London. But what I want to do is to calculate those averages not on the data level, but actually on the most granular transaction level. But I want to first aggregate the results on a type of property and then take the average of those averages. And the reason for that is that in some areas we have more office buildings, and these office buildings are generally more expensive than houses. So if I average that on type of property level, I will be able to spot where we have more offices. So let's try to do that. Let's try to calculate this using table calculation. So the table calculation for this example is really simple. Can you see it at the back? It's fine? Okay. So basically, it's taking the window average of the averages of the transactions. So if I drag and drop this value instead of our averages, although the color changes, actually the results don't change. So if you look at TW6, it's 40 million. If I go back, it's still 40 million. So if I want to change the way the table calculation works, I can edit that table calculation and define how the calculation needs to happen. So we have those fields that we can use, and because the data level or the viz level that we have at the moment is district, actually I can calculate averages only on a district level. So this is a problem. If I want to also bring the type of property, I need to drag and drop it into detail so that it appears as an option for doing the calculation. As we said, table calculations happen on Tableau, so you need to have all the information in order to actually do the calculation itself. So what happened now is that we have the averages, but all of them are detached houses. So what happened to the other types of properties? Actually, all of them are there. It's just that they're on top of each other. So I don't see the values for flats or semi-detached houses, etc. I need to filter or highlight them. So that's why when you work with table calculations, it's easier to calculate things in a more tabular format and then do the visualization later on. Let's do that. Because otherwise you will not see what's going on with the calculation. So as you can see, for each district, I have 5 types of properties: detached houses, flats, others, semi-detached houses, etc. And they have different average price. So others is the offices, and you can see that it's always higher than the houses. So what I want to do is calculate the averages of these 5 values and do it for each postcode, for each district separately. Let's do that. So as you can see, now that I have type of property and district, I need to tell Tableau what I want the calculation to use and how many times the calculation to happen. So both of them are unselected, but by selecting a dimension, what you do is tell Tableau to calculate averages by using that dimension. So I want the calculation to use type of property, averages by type of property, to calculate the secondary average. And by not selecting a dimension, I tell Tableau to do it each time for each, in this case, for each district. So anything unselected is how you group the calculation, and anything selected is how you apply the calculation. So in this case, we want type of property for each district to be calculated separately. And Tableau will show you actually by highlighting which part of the data, which part of the results it's using. So now we have the averages, and if I drag and drop the actual values back, I can see that these averages are calculated on a district level, but the problem now is that they're repeated 5 times for each calculation. So I don't want that because it increases the amount of data or results that I need to hold. So what I will do is I will create a simple index function which will be calculated exactly the same way. So I will say calculated by using type of property and group it for each district. So what it does is basically gives the numbers from 1 to 5 to each type of property and then repeats it for each district. Now that I have these values, I can use them as filter and say show me or leave only the first value for each district. So we'll end up having only one value per district. So let's create a map out of this, and let's just drag and drop this one here, and here we go. We have our averages calculated on a secondary level after we calculate the averages by type of property. And let's make it a little bit more colorful. Orange and blue, reversed, and then I'll say everything above 1 million is expensive. Good. So as you could see, it took me a few steps actually to calculate the results, and I had to introduce new data or new records in order to get there. Now let's see how we can do that using LOD. So with an LOD, I just need to write a very simple calculation because the LOD will go back to the database, so I can do whatever I want without bringing those records to my screen. So let's see that calculation. If you've been yesterday to the lots of fun with LOD, with level of detail expression session, you would know the difference between fixed, include, and exclude. But basically, include is saying, take type of property and district and calculate the average price. So not only consider what's on the view, which is district, but also take into account that there is another dimension called type of property. So what this calculation will do is first calculate the average price on a type of property level for each district. Exactly the same thing that actually the table calculation did. So if I drag and drop this one on the view, now it gives me the sum, but I can also take the average of the averages. So I take the average of the averages and do exactly the same coloring scheme, which is blue and orange reversed, and everything above a million is expensive. So if we look at now the two calculations that we did, they do exactly the same thing. So we have exactly the same results if I go to, again, our lovely TW6, which is a very expensive area apparently, and I check the calculation using LOD and table calc. These are exactly the same numbers. But one of them required me to write a simple line of calculation, and the other one required me to do multiple of steps and then even filtering on top of it. So in this case, LOD is a much better choice. Let's look at the second example to see the difference between these two. So in this case, what I want to do is I have the averages of the houses, not on a district level, but like a larger area on a borough level. And I can see that, and I can see the averages of those averages as well as a reference line. So the average of these numbers, which are on borough level, is £361,000. So now what I want to do is to calculate the difference between the average by borough and the overall average. So for example, for Barking, it will be a negative value, whereas for City of London, it will be a positive value. And I can see comparatively which ones is more expensive than the average boroughs. So let's do that with a table calculation. First, the table calculation is very simple actually. So it uses exactly the same logic that we had for calculating the averages based on type of property, which is taking the window average of the average price. So if I drag and drop this part of the calculation here, I'll see that this calculation is exactly equal to what we have as the average reference line. So if I just take the difference between the average on a borough level, that would do the trick. And the only thing that I need to write is average minus average price, because I already have that information on the view. And I know that it's on the borough level, so everything is fine. So let's drag and drop this calculation here. Just a second. Let's do that again. And now we can see the differences, right? As we expected. So let's try to do exactly the same thing using an LOD. So the LOD calculation will be similar to what we did before, but instead of include, this time I will use exclude, meaning I have borough on the view, but do the calculation as if borough is not there. So if I drag and drop this calculation to see what the result is, you'll notice that the result is a little bit different than the average that we have on the reference line. So does anybody have a clue why this can be the case? Yes?
Is it to do with averaging averages, which is always a bad idea? Is it one's an average of an average?
No, not really. Any other guesses?
No values?
Sorry?
No values?
No. So, if I get rid of the borough, what do I end up with? I end up with the average of the price, basically. So it goes and checks every record in the data and takes the average. If I get rid of borough, I will see that these two numbers, average price and my calculation, are exactly the same. So this gives me only the average of the transactions in the whole data set. What I need to tell Tableau is to take the average before getting rid of the borrow. So what I need to tell Tableau is first take the average on a borrow level, then get rid of the borrow. And it requires me using a fixed calculation. So I will say on a borrow level, calculate the average prices, fix them, and then when I get rid of the borrow, because I already have these numbers, it will just take the average of those numbers. Like this. So let's close the calculation as well. And if I drag and drop now this calculation, you will see that it's exactly the same as the reference line. So the first part of the calculation, the fixed part, basically calculates all these numbers. And then the second part of the calculation gets rid of the borrow as a level of detail, and then takes the average of those numbers. So now that I have the average, the only thing that is left is to take the difference between those two numbers. But once I write the calculation this way, Tableau gives me an error message, and it says that it cannot mix aggregate and non-aggregate calculations, because the level of detail happening on the data level is actually a disaggregate calculation. So what I need to do to fix it is to aggregate it somehow. But it actually doesn't matter whether I use minimum, maximum, average, sum, whatever, because I have only one number being repeated many times anyway, so I can just take the minimum of that number. So now if I drag and drop this one, we'll end up having exactly the same result that we had with the table calculation. But as you can see, it required me to write a quite complicated nested LOD calculation to get to a point which was so easy with the table calculation. So let me get rid of this. So when you look at these two examples, one of them, the first one with the map, it was good to use an LOD, and in the second one, it was good to use a table calculation. Can anybody answer now why we had to use LOD in the first one and in the second one a table calculation? Any guesses? No volunteers? Let's just recap what happened. So in the first case, we had to go back to the data set and bring records which didn't exist on the initial view. Whereas on the second calculation, or on the second example, we already had everything that we need to do the calculation. So we already had all the numbers pre-calculated, and the only thing that we needed to do is take the difference between two numbers. So the first takeaway is basically that when you have all the information already on the view, it's actually much simpler to use a table calculation, because you don't have to do anything else to calculate the result that you want to get. But when you need to bring more records from the data and keep the visualization the same way without introducing complexity, then you need to use an LOD expression. Otherwise, you need to go through many, many steps to get to the same point with a table calculation. So all the information is there, use a table calculation. You need to go back to the data set, use an LOD. Any questions so far? Yes, please. We'll come to that point. Yes, that's actually one of the things that I want to discuss. But after flexibility, if it's okay. So first, let's discuss also flexibility of the calculations. So we saw how to decide a simple way of calculating things. What is the driving, let's say, criterion? let's talk about flexibility. So what I want to do is to check how the average prices moved in the period. So what was the trend? So if you look at the average transaction values over, let's say, on a monthly level, sorry, let's not use this one. Let's use the number of transactions. It's a better way of seeing things, and actually it shows us a little bit more. So if you look at how many transactions happened in London over time between 1995 and last month, basically, you'll see that there were around 15,000 transactions per month up until 2007 when the financial crisis happened, and it dropped dramatically, and it never recovered actually, and now because of the Brexit thing, it's going down again. So yes. So what we want to understand is which borough or which neighborhood in London became more popular over time. So where we have more transactions. So to do that, I will bring borough to the view, and it will be a mess. But what I can quickly see is that City of London is an outlier, so we don't have many transactions in the city happening. And Wandsworth, I guess it's pronounced, is, you have the most transactions there. But looking at this data this way, we obviously don't understand what's going on. So if I want to see which one is becoming more popular, I need to compare the relative numbers. So I need to take percent of total, basically. So if you're aware with table calculations, you probably know that some of them are pre-programmed. So we have something called quick table calculations, which you don't have to write calculations for. And they are found under the measures. So if you click on the measure and go to quick table calculations, you will see the calculation or analysis types that you can do with one click. So these are running totals, differences, moving averages, etc. And one of them is percent of total. So if I select percent of total, you'll see that this axis now changed to percentage. But obviously Tableau will default to calculating it one way, and we may want to calculate it differently. So in this case, Tableau takes the whole data to calculate the percentages. That's why they're very small. But what we want to do is to have it blocked or bucketed for each year. So what I will do, I'll say calculate it taking the borough, but group it for each month, right? So I'll take the selection out of the month. So now we can see, let's say, how Barnet was trending compared to the rest of the boroughs, etc. But it's really very hard to see which one is growing and which one is getting less popular. So what I need to do is use a filter. So if I use the borough as a filter, let's say, and if I select a single value, what happens is that now I have, for each month, the same result, which is 100%. And this is not exactly what we want, because this doesn't give me any information. And the reason for that is that the table calculation, taking into account what's on the view only, now that I have only Barnet or Barking on the view, it compares Barking to itself, and it's always 100%. So it's not exactly what I want. But it was a very easy way to calculate it, right? So sometimes simple is not helping us. Sometimes we need to use the complex way just because we want to also do other stuff with the result. So we want to extend or expand the way we want to use the results. And let's call it the flexibility of the calculation. So in this case, the table calculation is very simple, but it's not flexible. That's why we now need to go back to our a little bit more complex LOD, but to get to that point where we can actually apply filters. And because the LOD will happen in the data level, the filter will not affect our results. So let's do that. I'll actually start from here. So here is the calculation that we will use. The problem with this calculation is not the results for the individual borrow. It's the denominator. Because the individual borrow calculations, we have them even after filtering. But because the denominator now takes only those values as well, we end up with 100%. So what I need to do is keep the numerator the same as what we have on the view, but change the denominator to a level of detail calculation. So if you look at this calculation, what it does is it calculates the number of transactions for each month and year and fixes them to those months and years. So I can look at calculating the results this way. I can look at the results on a monthly level, on a quarterly level, or a yearly level. But I cannot look at them on a weekly or a daily level because this calculation doesn't have that level of detail. But that's fine because I need to go to monthly level only anyway. So let's drag and drop this calculation and see what's going on. As you can see now, we have exactly the same results as the table calculation, but with one difference, and that's the ability to actually apply filters. So if I go and apply exactly the same filter, let's say for barking, now I end up with the percentages that I exactly want. They are saved, they are fixed, and now I can see whether barking becomes more popular over time compared to the rest. And one borough, which is actually I assume that became very popular, is Tower Hamlets, which is Canary Wharf area, because there are so many new developments there. So if you select Tower Hamlets, you'll see that it's actually getting slowly more and more popular. Okay. So what was the reason for this hiccup, let's say, with the table calculation? It has something to do with the order of operations that Tableau uses to do the calculations. So if you remember, hopefully, the maths classes where you have brackets and pluses and multiplications and divisions, you know that you need to do them in a specific order, otherwise the result will be wrong. So Tableau works exactly the same way because so that you can get exactly the same result every time that you do the calculation. So we start with filters, like database filters, so that data will never come to Tableau. It will not be used for the calculations. And then we use something called context filters, which is not important at this stage. But then, if you look at what's happening after context filters, we have this fixed LOD calculation. So that fixed calculation happens before the filters are applied. So it will always give you the same result no matter which filter you apply. And why it didn't work with the table calculation? Well, because table calculation, being at the bottom, happens after the filters. So it's like adding salt to the food after you ate it. It doesn't work. So you know that you need first to add the salt and then eat it. And the fixed calculation is adding the salt up front, basically. So it needs to be in a specific order, otherwise your calculations will give wrong results. Well, actually they are not wrong, they are not what you are trying to achieve. Okay. So let's come to the third part of the triangle, which is the performance. So performance is obviously very important because there may be a case where you, just because of the way you apply the calculation, you can use all the resources that you have on your computer. So to see how calculations may affect performance, we'll start using a similar to the first one example. Our number of transactions, this time we look at the number of transactions on a district level. And what I want to do is to check how many transactions on average we have on a daily basis. So how many, if we are in this district, E16, for the 23 years of data, we had 17,000 transactions. But how many transactions on average we had each day? That's an interesting question, isn't it? So, and we can do that with the data. So let's start with a table calculation. We know that already from the first example, it's much easier if you have the data in front of you to understand what's going on. So in this case, I have the district, I have the transactions per year. What I want to do is calculate the average. Then I will go to the monthly level, to the daily level, etc. But let's see what's going on if we do that on a yearly level. So we have this calculation, which is not very different from what we had at the beginning. It's taking the averages, but instead of averaging the average, it's averaging the total numbers per year. So let's drag and drop this one here. And the first thing that Tableau will do is calculate the average. We can see that average is 462 transactions per day. But if you look at the calculation and how it has been done, it's actually taking the district and the year at the same time, but we actually want the calculation to happen for each district separately. So I will unselect district. Okay. Now we'll have different results for each district. Now, if we go to the quarterly level, just by clicking on the plus sign, we'll see that now the calculation is not correct because we introduced a new dimension, and I need to correct my calculation and say, I want you to take also the quarter into account because I have it as a detail and calculate it on a district level again. So now we can see that on a quarterly level in the district BR1, there were on average 265 transactions. The problem is that if I go this way, when I reach day level, probably you don't see the marks here, but at the moment we have 53,000 calculations happening on the view. So when I reach the daily level, I will have around 4.5 million. Obviously, this will not scale. 4.5 million calculations on the view is not something that we want to do because it will not scale, especially, this is an average amount of data, but imagine that you have millions of records. This table calculation will not be a good way to calculate it this way for this specific case. Let's see how it works with an LOD expression. In this case, actually the LOD expression is also simpler in a way because if we look at the calculation itself, it's basically calculating the number of transactions on a daily basis. So the date trunc function, let me show you, just for the people who may not be familiar. What date trunc does, it takes all the values for the period that you specify, day, week, month, etc., and truncates them to the first day of that period. So everything that happened in one specific quarter, I can truncate to the first day of the quarter, and because it's the same day, Tableau will treat them the same way. So in this case, if I just change the calculation from day to week, I will calculate the weekly averages. If I change it to month, I will calculate the monthly averages, etc. Okay, so let's drag and drop this one on the view. And because the calculation will happen on the database level, I end up with 604 results on the view instead of 4.5 million. And as you can see, it just gives me what I want. Obviously, I need to take the average, sorry. So when we take the average, we'll see that Croydon is the most popular, let's say, district with about 10 transactions each day on average. So what are the takeaways? When you use table calculation, you need to also understand at what level that calculation needs to happen, because if it's like very granular level, because you need to bring all the data on the view, you will end up with having too much data just to do the calculation. It doesn't make sense to bring all your data just to do one calculation, right? Whereas LOD expressions don't have to have the numbers or the results on the view, but this time you need to be careful because they happen on the database level, they will be limited by the performance of your database. So even when you use LOD calculations, just make sure that the database that you use is also fast and good performant. Okay, so now we have a few interesting examples, like rankings, recursive calculations, moving calculations like moving averages, inter-row calculations where you need to refer to different parts of the data. So let's see a few examples of those. The first thing that I will do is calculate a moving average of the median price for the houses or the properties in London for the whole period that we have. So let's do that. Again, we can do it on a monthly level. And this time, instead of the average price, I'll just check the median price, which is a little bit less scary, I guess. So this is our median price over time. But let's look at because as you can see, there are many fluctuations. I want to see what's the moving average over 12-month period. So I'll use a quick table calculation, select the moving average, and edit that calculation to take into account the previous 12 values. Okay. Now, if we create a dual axis out of these two calculations and synchronize the axis, what we'll see is that for a very big number, like for almost all the period, the moving average was below the the moving average of the median was below the median price, except maybe this period, which is like 2008 and 9, which is the financial crisis. I'm not very good in trading or whatever, but I think that if the moving average goes above the value, bad things happen. As you can see, financial crisis, etc. For now, it seems that we are fine, maybe not, who knows. Okay, so it's a little bit below, I guess. It may go above. Okay, this is one example with the moving average. And now, imagine that you want to try to do that with an LOD calculation. Do you think that is possible? No idea. Maybe, I don't know actually whether it's possible, but it will be very, very hard. Probably it's not possible. Because what you need to do to calculate this moving average is to check 12 periods before every time, and the calculation that you will do will be very static. It will not be able to do these loops where it checks 12 periods before for this month and then 12 periods before for the next month, etc. But there is one calculation maybe which is very easy with table calculation, but you may also do it with LOD as well. It's the ranking calculation. So if you look at let's say the boroughs, and let's say for each year we want to see what were the most popular 5 boroughs in terms of number of transactions. So it's a calculation that again is a quick table calculation. So I can just select it and then specify that I want it to be calculated for each year and repeat it for each borough this time and repeat it for each year. And now that I have this calculation, I can even use it as a filter and say, show me the top 5. And if you go down, maybe put a little bit of color so that we can see the different boroughs. So we can see that Tower Hamlets became very popular in 2016, but then it dropped for other boroughs. So it takes less than a minute to calculate this with table calculation. You can probably calculate this with LOD as well, but you need to write every calculation separately. And because the ranking happens, we don't know how many times we need to rank something. The ranking can go to thousands, basically, depending on the data. Obviously, we'll not want to write 1,000 different calculations. So maybe for top 5, it will work, but once it gets more than that, it becomes very tedious. So for this type of recursive ranking, moving calculations, inter-row calculations, etc., as you can see, table calculations are much simpler. Because with table calculations, you can write the calculation once or call the calculation based on one specific part of the data, and it will return many results for the same data point. Whereas with LOD calculation, you get only one result per calculation. But LODs can be very advantageous if you need to create something like a dimension, for example. So what we'll do is try to see where are the most popular postcodes, in which districts we have popular postcodes. And how we will define the popularity is if we have more than 100 transactions that happened in that postcode. So every district has a postcode in it, and we have about 135,000 postcodes. So some of them are popular, some of them are not. And let's say that 100 is our reference line. I'll just add it as a constant line. Here, 100. And if I scroll down, I basically want to count how many of those postcodes are above 100 for each district. So the calculation for that looks like this. So basically what we say is for each postcode, count how many transactions we have. Why do we use fixed calculation? Because now, knowing how many of the postcodes are popular, I want to count how many popular postcodes we have in each district. So what I can do with this calculation is use it as a dimension. So I can drag and drop it up into the dimensions pane and actually use it as a dimension. So let's do that. Maybe I should erase it like this. So if I drag and drop the dimensions, I'll see that we have postcodes where we had 1 transaction, 2 transactions, 3 transactions, etc. So let's see how many postcodes had only 1 transaction. So it's expected, right? It's exponentially dropping. But basically, we have 8,000 postcodes where for the 23 years of period of time, there was only 1 sale. Isn't that interesting? But then we have some postcodes which are really, really popular, up to a few hundred of sales. So let's, as we defined, 100 is our threshold. So I'll just filter for the popular postcodes, the postcodes that had more than 100 transactions. Now, what I want to do with this filtering is to see how many of these postcodes are in which district. So if you look at the values like this, we'll see that in E14, which is Tower Hamlets, we have 129 popular postcodes as we define them. And then you can quickly see which other districts are with popular postcodes as well. So in this case, because what we wanted to do with the results was actually use them to summarize the data, we had to use a fixed calculation, because with a fixed level of detail calculation, we can basically create new dimensions, which can be, as you can see, very useful to summarize the data on a different level that didn't exist in the data set to start with. So the last example that we have has to do with data blending. So data blending, if you're familiar with, is basically taking 2 data sets, and instead of joining them to create a larger table, is to keep them separately, but to be able to refer to them at the same time. So it's like joining the 2 tables, but only on Tableau level. In this case, I have the property the transactions that happened in London, but I have another table which has only the income level in these boroughs. So what I want to do is to bring these 2 tables together in Tableau and try to understand the housing crisis in London. So if I go to the second table, you'll see that Tableau automatically made a connection between the borrows because they have the same, basically this is the common key between these two data sets. And if I drag and drop borrows from the second data set, you'll see that they match except for City of London. So we have null there. Okay, so we have the average price for each borrow, and I have also the average household income in those borrows. What I want to do is calculate how many yearly salaries you need to buy a house or a flat. So the calculation is very simple. It's basically dividing two numbers to each other, the average price divided by the average income. Although these results come from different tables, because we have a common key, we can join them on Tableau level. So if I drag and drop this value here, you'll see that for each borrow, I have the amount of salaries that I need to buy an average house. So now, let's look at this on yearly level. So if I drag and drop here and get rid of this, maybe apply this as a filter, show filter, and then even get rid of the borrows, and now we can see the results on a yearly level, right? Let's apply a line chart. So we can see that on average, so the income data is only for 5 years, but it's enough to see the drastic change. So in 2010, I needed 8 salaries on average to buy a house, and in 2015, now I need 11 yearly salaries. And you can look at this data basically for every borrow separately. And what I want to see is how much more I need to earn for these 5 years. So if I look at the percent of difference and then calculate it using the first year that we have in the data, we can quickly see that we need to be 35% richer, basically, to actually buy a house just in 5 years. And obviously, for many people, that's not an increase in salary that they see, so we end up in this situation where you need to use 2 different tabs, basically. So what's the takeaway from these few examples is that we have some, let's say, edge use cases where using table calculation or LOD will be a better choice. So table calculations are really good when you use data blending because they can apply for data blending. So data blending happens after the LODs. Given the example with the salt and the food, you cannot do LODs after data blending. That's why but you can still do table calculations, so we can use them for this type of scenarios. And also, when you have recursive calculations, that, these for loops, whiles, etc., or inter-row calculations, table calculations are much simpler to apply. Whereas when you need to create a new dimension, something that you need to summarize the data on, but doesn't exist in the data at the first place, an LOD expression would be a good choice. So, let's go back to our presentation and have a look at the framework that we created actually in a very simplified, generalized manner. So there are a few questions you can ask yourself before actually deciding what calculation to use. And the first question is it a recursive ranking or moving calculation or inter-row calculation? Because if it is, then I will just do a table calculation. I will not even bother to write a LOD for that. If the answer is no, then I can ask myself, do I have blending in the data? If the answer is yes, and I need to do the calculation after the blending, then I will again use a table calculation. No need to write an LOD. But if the answer is no to this question again, then I will go to the third edge case, which is, do I need to write a new dimension? Am I going to use this result to summarize the data differently? If the answer is yes, then an LOD calculation will do the job. But obviously, all these three use cases will happen, let's say, rarely. Most of the time, the answers will be no, no, no. And then you'll end up with the most important question. Do I have all the information on the view? If the answer is yes, I will just write a simple table calculation, and I know that the result will work the same way as an LOD. But if the answer is no, and if I need to go back to the database, instead of bringing this information with drags and drops and making it more complicated, then I'll just write an LOD calculation. So you can have a very, granular framework as well with many, many, many more questions in between. But I think this generalized framework is giving you the basics to actually decide how to write, which type of calculation to use. So do you have any questions so far? Yes?
What happens if you have a dashboard in Tableau that is where the user can switch dimensions in the dashboard?
Okay.
Yeah.
Oh, you mean like they can actually decide what dimension to see?
Yeah.
So then you need to take that into account and write the LOD calculation taking all the dimensions into account. So the LOD calculation will be a little bit longer because you can put different dimensions in the dimensionality level of the LOD. Then you need to apply all of them upfront because you know that people can switch in between. Otherwise, the results may be wrong. I can show you in the break an example. Any other questions? No more calculations. Yes, please. Mm-hmm.
But is there a difference in table calcs versus LODs when you don't have a systematic?
In terms of performance?
Yeah.
If the marks are low in terms of numbers, there is a big chance that the table calculation will be actually faster because you do the calculation on small amount of data, whereas the LOD needs to go back to the database, needs to check all the data, etc. So I guess when the marks are small number, table calculation will do better. If you don't have the question whether you have all the information, if everything is there, just do a table calculation. Okay, so if you have any other questions, please let me know. One thing that probably everybody told you is to rank this, not rank, to provide, say that it's the best, to actually give some ratings and comments which are very useful to make these sessions better, more approachable, etc. There are a few related sessions today that you can go. It's greatest analytics of all time with time-based analysis, which will be by Ioana, my colleague, and then the all-famous Bethany in the afternoon. She will tell a very personal story about what happened with her in her life. For the people who are local or are going to stay in London or are going to visit London in the next 2 months, I also have some recommendations of what to see. So this is a very nice installation called the Mastaba by Hristo, who is from Bulgaria, the country which I come from, and I think it's very worth it to see because it's fantastic. It's like more than 7,000 oil barrels in the Serpentine Lake. It defies space and time. So go and see it. It's going to be on display by September. And because we talked about construction and how to put things together in Lego blocks, I think it's a very good example of what you can achieve with good engineering. Obviously, because we talked about Lego, you can also go and see the Lego store on Leicester Square, which they claim is the biggest one in the world. And this session is not sponsored by Lego, not at all. So if you are wondering where they are, I can help you as well. So this is our office in Southwark. It's just next to Tate Modern. So if you're going to visit Tate Modern, you can also see our office. We can wave. And the Lego store is in Leicester Square, and the Mastaba is in the Serpentine Lake in Hyde Park. I hope you enjoy the rest of the conference, and I hope that this session was a good choice. So thanks for being here, and see you later. Thank you.